who don't like Grafana. So almost every database have an integration with it, but we probably is the only database that can show streaming query in Grafana without the dashboard refresh. Welcome to the monthly webinar of Timeplus. My name is Jove, the head of product at Timeplus, and also today's host. So joining me is Ken, our chief architect, and our special guest, Jason. You will learn more from him shortly. So today, the main topic is the integration of Timeplus and Grafana. And we will also talk about what's new in Timeplus, Timeplus Enterprise, and Timeplus Proton, and we are be more than happy to take any questions in the end. So this is recorded, and we are going to publish this in our YouTube channel, share on the linking. But if you are here during this live, feel free to ask questions. And if you can share a little bit more about yourself in the chat, that'd be great. And our team member are going to answer those questions and contact you later. We are going to talk about what's new in Timeplus, but if you are new to Timeplus, so just let you know that Timeplus is a unified streaming CQ engine, and we provide good high performance and efficient as a single binary. It is widely used in many different use cases, including the DDoS detection, the log analysis, IoT. We have nice integration with Kafka, with Pulsar, with ClearHouse, and all using CQ, the language you are familiar with. We'll start by introduce the integration of Grafana and Timeplus first. And I will share a quick demo so you can see how this works in the basic way. And our guest, Jason, is going to share more about how he used this in his use case. I have both Grafana and Timeplus. And if you want to set up this, it's very easy. In the Timeplus side, we can just download the binary. It's quite small and just start it. And in the Grafana side, you can install our latest version and put this into the Grafana plugin folder and unzip it and start it. So back to the Timeplus side, and I can just create a sample data source. For example, I can choose the Coinbase, which is a live data feed about the latest Bitcoin price. And I can give a name, say Coinbase 2, how about that? So what it's doing that is it will connect to the WebSocket of Coinbase and get the live data and put into a data stream in Timeplus. And you can see we can just using SQL to query it. And if you just want to know what's the latest price, you can just using choose the TP time column as well as the price, and then run again. So we can use the Grafana plugin to visualize this data without a refresh. So back to the Grafana, and because this is already installed in your deployment, we can just create a new dashboard. I already have one, but if you want to add a new panel, it's quite easy. Just choose the visualization and choose the data source, which is Timeplus. And you can paste the CQ or write your own CQ here. We even support things like join, and you can run the query. By default, it's last 6 hours, so you can even switch to last 5 minutes. And you can see this chart is refreshed, or it's updated automatically without a refresh. All the chart options is available, and you can change the time zone, you can change the format and add back to the dashboard. Again, this is just a simple demo how to integrate Timeplus with Grafana, showing any live data. It can be coming from the Bitcoin, can be from Kafka, from any logs. But I think our guest, Jason, will have something more interesting to share with you.
Thank you, Joe. So my name is Jason. You can read all about me on the screen there, but I won't regurgitate all of that. But I've been in the broadband industry for a long time, since forever, pretty much. And I've worked kind of on all aspects of it. I've been an operator running, cable modems for customers and things like that. I've also worked on the manufacturing side, where I worked for a supplier of that equipment, and now I work on the reseller side. So I've kind of seen it from several different sides. But I have a passion for helping customers to help their customers, helping my customers help their customers, and the way that I do that is help them with better monitoring and stuff like that. So at RocNet Supply, one of the things that we're working on is uh, is a new software called Data Harbor, and it's aiming to solve a couple of problems. So a little background on this that'll make it a little more sense to you if you're unfamiliar with the problem that I'm trying to solve here is in the broadband industry, specifically in the DOCSIS or cable industry, the device that your cable modem connects to on the other end is called a CMTS, and it's a networking device, kind of like a switch or a router, but it has a big difference between a traditional switch or router. So, like on a switch or router, you would traditionally manage all the interfaces, like how many ports does it have, what are those ports doing, things like VLANs. I'm not trying to get too technical, but they'll have a list of things that you can manage in there. And for a regular sized switch or router, you'll have tens or maybe even hundreds of interfaces that you need to manage. On one of these CMTSs that manage broadband, they have significantly more. So they could have anywhere from 5 to 10,000 interfaces, and also they have all the cable modems they have to manage behind that too. So the amount of items you have to manage behind a CMTS can be significantly higher than like a traditional switch and router, even though they do those same that same functionality, have switching and routing capabilities, but the amount of things you have to monitor and keep track of is exponentially larger. And because of that, in the industry, there hasn't really been a good way to visualize that data in any meaningful way because of the large amount of it. And so the compromise that most operators make is, okay, we're going to get a small amount of that data and we're going to pull it every 15 minutes because they can't pull it in large enough chunks. So the software we're working on is working to solve that problem by grabbing all of the data all the time. And we're doing that with streaming telemetry.
Right.
So streaming telemetry adds a little bit of a different problem to that is because of that large amount of interfaces and things like that. In a CMTS, they're all interrelated, right? So sometimes, like to find one piece of information, you need 7 other pieces of information to be able to know what you're looking at, and it's all intertwined. And that makes using traditional network monitoring tools very difficult because a lot of times they don't support things like joins and things like that in time. So Timeplus is a good fit here because it solves that problem. One, we can aggregate our data in real time, bringing it in through Kafka and then ultimately to Timeplus using streaming telemetry. But then we can also combine our data. There's a feature that I'll show in a minute in my demo called as of, which allows you to combine tables that don't have exact matching timestamps, which is exactly the use case for streaming telemetry. And it allows you to combine basically rows from different tables at different that are collected at different rates or intervals. Um, the other big problem that we run into in this world is uh, a lot of it is based on counters. And so the way the counters work in the networking world is they're either a 32-bit or a 64-bit counter, and then when they fill up, they reset back around. And so if you collect counters, the counter by itself, like if you just have one data point, a counter by itself is pretty useless. You need 2 data points and the time that they were both captured at, so you can figure out a rate. So one of the really cool things that Time Plus allows you to do is as it's ingesting all this data, because it can see the data coming in and it's sending it out, it can calculate the rate at that thing. So by the time I look at it in Grafana, which I'm going to show you in just a second, I've already calculated the rates and I have it. So in the database world, this would be called, instead of extract transform load, it would be extract load transform. So it makes it a lot easier, and then you still have access to the counters if you still need them for some particular reason. So now on to Grafana. So basically, what we're bringing in is a whole crap ton of data into Timeplus and using our Data Harbor software. And what we're going to put on the back end of that is we're going to have a bunch of visualizations, dashboards, graphs, charts, which I'm going to show you in just a second. Plus, we're going to find problems as they occur, do alerting. We're going to give you a lot more insights like what's my capacity look like, all these things are very difficult to do with limited amounts of information. We're going to try and give you all the information and be able to make informed decisions on what your product's doing. All right, let's go ahead and move into the demo real quick because that's what everybody really wants to see. All right, so here's an example of an upstream interface. And just to show you kind of the idea of how many interfaces there are. So this is a lab device. It only has a few that are up. But if I turn it to show like all the ones that aren't turned up, you can see that there's hundreds, if not thousands, in there. And on some of the other ones, there's even more than that. But anyway, so we're looking at this graph here, and it's got all the data that's all intermixed together. We've got like just regular data that's useful, like configuration data in the networking parlance, as well as some state data in here. And in the Grafana, this little green dot here means that it's streaming. So that means that not only am I looking at the last hour from an hour ago till now, but from now forward. And so it's just constantly updating. And if you watch this little timestamp here on all these columns right here, right here, and right here, as the data updates about every 30 seconds, you'll see them all update. So they update sometimes all together, sometimes a little bit different. It has to do with how it backs up. So you saw it right there. So they all kind of just did, and it took a second for this last one to go. But that's really cool. So you don't have to sit here and refresh your screen. I mean, Grafana has an auto refresh that you can turn on where like every 5 seconds it refreshes your screen, but it redraws the thing every time. So this is a much better improvement, and it's called Grafana Live. So it's part of Grafana, but this makes it useful. And then to give you an idea of why this is difficult before, let me show you what a join looks like. Oops. There is my screen. So like I'm looking specifically at the source SQL for this. And this is in Timeplus. So I'm having to grab multiple pieces of data and join it with multiple other tables just to get that particular amount of data. And so if you run that, you can see it down here. It's doing the same live query where you get the data. And so this adds a new thing that's not very common in this world. I'm sorry, in this space, where you can look at all the data all the time. And that's something that hasn't existed in this space, and we're trying to bring it there. And Timeplus makes it really easy. And it's a very, very useful tool, and I really like the Grafana. It's been a pleasure to work with. Back to you, Jove.
Yeah, thank you, Jason, to share this awesome use case. And as I mentioned earlier, that is we create this integration, but your use case is super interesting, and even invented some new ways to use it, such as defining the variables and auto switch. So let me do a quick summary. Yeah, as you can see, that is we really bring the best of two worlds together. So using Timeplus, you can easily connect to the data in Kafka, in SMP, in other source, and query them using SQL. You don't have to learn a new language. And you can do the SQL-based data enrichment using join, using different fixed size window or sliding window. And as Jason mentioned, that is in many cases, the data in different source are not really, they are related, but the timestamp may not be exactly the same. So using the powerful as of join can match the events together. And also Timeplus can query the data in Kafka directly, but we can also move the data in Timeplus, and we provide both column storage and row storage, and with a lot of different high-performance query functions. And on the Grafana side, we're leveraging all the available built-in charts, as well as the hundreds of panel pounding in the market. And we are leveraging this Grafana Live framework, so you don't have to set a refresh on the dashboard, and also the data will not be keep rescanned. Using some advanced settings such as time picker variables and annotations, you can enrich your Grafana dashboard to set a better threshold, and using the built-in version control and access control to refine the Grafana dashboard, provide better visibility or troubleshooting abilities. So yeah, thank you, Jason, for sharing this awesome use case. And we are going to talk about more in a blog coming soon. So moving next, let's invite Ken, our chief architect, to talk about hash table join, and which is one of the biggest feature in the recent release. Over to you, Ken.
Yeah, so hello everybody, my name is Chen. Yeah, so I like to share some of the key use cases about the hybrid hash join and the hybrid aggregation. So basically the underlying technology is basically hybrid hash table. So it means that if the memory is not enough, we need to spare the data on disk and do the on-disk join and aggregation. So but from a high level, the typical use cases is like high cardinality data and streaming incremental query processing. And also regarding the data mutation, high cardinality data mutation as well. So we have some of the use cases later, and also a cool demo later. So like user case one, so user like to do a streaming join with dimension with a factor table like orders. Orders is basically coming is always flowing into the system, and also there's the products. Orders need to join the products, and there will be many of products, like 200 millions of products. Imagine Amazon, Amazon, the shopping website. So there will be millions of or even billions of products to join. So in order to do this kind of streaming join and data enrichment, there will be lots of very big dimension table to join against. If we need traditional regular database, basically I need to build a Hashi table, and the Hashi table is basically in memory, and that will be blow out the memory very easily. So in our case, basically, for example, we can do the streaming aggregation, streaming join orders with products in this example, and also we can turn on the hybrid Hashi join equals hybrid. We can using the hybrid Hashi join on the line, and also if there's more data flows in, and we can join on the right hand side we have products, and most of the data basically are on disk. Since in streaming query processing, data is basically highly temporal. So that's a very typical hotspot of data. And we actually cache the hot data in memory and also spare the cold data on disk. And most of the time we do not need to touch the on disk data. So we have very good balance between the memory utilization and the join performance. Joe, next slide, please. Another use case is basically blockchain analytics. So user basically like to put billions of keys in our mutable stream, and also do the millions of keys, hundreds of millions of keys aggregation. So, but the data is not changed often. It's basically changing infrequently. But every single time there's a change, please update me the change. I do not want to need to rescan of the data, reprocess of the data, and do the repeated query processing. So in Timeplus, it is very easy to do this by using by enable hybrid Hashi table, and along with the emit strategy. For example, emit periodic 1 second on update means that every single second, if there's any update for the new keys or for the existing key, project the aggregation result to me. And user do not need to rescan all the data. And by enabling Hashi table, basically hybrid Hashi table, we basically bring down the whole memory utilization. From previously we have user in production, basically user has 10 material view query, and it basically uses 180 gigabyte of memory. And by enabling the hybrid Hashi table, we bring down the total memory consumption from 180 gigabyte to 20 gigabyte. For the 10 queries. Next slides. And otherwise, high concurrent sectionalization. This is very typical in the log analysis, the trace analysis. For example, there will be a lot of high concurrent open tracing, and the user like to do the outlier as a latency analytic in real time. For example, if my call trace has violated the SLA, like latency, like for example, 500 milliseconds every single call chain, because this microservice call chain is can be span very big. The time span can be very big, and if we like to, there will be lots of high concurrent, call trace. There are millions of concurrent sessions, the open trace sessions. If we're holding all of the data in memory, that would be very high memory footprint. So we can enable the hybrid Hashi table again for this high concurrent sectionalization case. The other one is basically a very simple one. Is basically high concurrent deduplication, very easy. So user has an external Kafka topic, and they like to deduplicate all of the keys, because it's really hard to do exactly once data ingestion in Kafka as well. So user like to do the deduplication. When the key grows, almost infinitely, and we cannot hold all of the keys in memory. This is another typical use cases in Timeplus. This example is basically a little bit more interesting. So since that this is related to the hybrid hash join, as well as data mutation, data revision processing. So we have the stock orders, we have the stock price. Stock price is basically changing, it's frequently changing, like changing 3 times per second for every stock. And the stock orders is also come and go. So we like to do the join these two together. This is bi-directional join. It's a little bit different than the data enrichment join in the shopping cart use scenario. So it's basically whenever left side orders has changed or price has changed, please calculate the market value for my account for stock account in real time. And in production, basically, we have customers that have a lot of products, a lot of accounts, and holding everything in memory also consume a lot of memory, because there's a lot of material. It's not just one single material. There will be hundreds of material going there, and as time goes, there will be more. The aggregated memory consumption is big. And after enable the hybrid hash table, hybrid join, the total memory consumption has going down. And also for this query is basically user do not need to do for loop query. Yeah, every single time, basically when there is any update to the price orders, we basically project the market value to the end user, refresh without any kind of refresh. Next slide. So this is the internal data processing pipeline. It's a little bit more complicated, but in general, we have lots of in the data processing pipeline in lots of pipes. We basically spear the data to the disk if the threshold has reached in the configure settings. So for example, on the left hand side, we have multiple stream on disk. We have in the aggregation, we have changelog converting aggregation. And also they can spear to the disk to save the memory. I like to do a very quick demo. This is a very interesting demo, and it is pretty hard to do this in regular database. It's basically like I have 100 million keys, and whenever this update to some of the keys, please update the user with the latest aggregation for the updated keys only. The query is very simple. Just like I have a transaction table. I have a transaction stream, and we aggregate because one account can have many transactions. I group by the account ID and to calculate the total sum of the amount. How many amount in total for that account ID, and also emit the aggregation result to the end user in real time. Yeah, there were several things happening here. So like this is a mutable stream. Mutable stream is really easy to handle the data mutation and data revision, and the transaction ID is basically the primary key. And also we have the secondary key, the account ID as the secondary index in the key. And also on this panel, Timeplus basically right now has 8 GB of memory utilization. I like to do the run this query. So do the aggregation for any account which have the aggregated total amount which is like more than 4 million, please give me the results. And we run this one because I already have the data, and it keep going. And on the left hand side, we basically say the CPU utilization. But we max out the CPU usage, and also memory utilization is like from 5 GB memory to 6 GB memory, and it grows slowly. And also on the disk side, we spear a lot of data. We spear a lot of data on disk. This is the query ID, and also this is the query pipe. Each of the query pipe has different hybrid hash aggregation and hybrid hash and also changelog conversion. So as time goes, it's already progressing to 72 million. I have 100 million in total, and 64 million account, 100 million transactions, 64 million accounts. And I'd like to show the so after it's done, I like to show the most critical one, which is the data revision. The memory utilization is still like 6 gigabytes. It didn't grow. It's grow very slowly because we build most of the data on disk. Yeah, it's still like very stable. If we are using in-memory join, it basically blow out my whole memory. So we can do for example, for this account ID, the total amount is like 4,300,000 4,323,000 amount. I like to let's do a quick query about the details for this account. This account is like put the account ID. Since that we have a secondary index for this account, so the point query this account is very fast as well. Also, we have 100 million rows there. So we have this for this account, we have multiple transactions, and the sum of the amount is basically the sum of the 4,323,000. So what I like to do is basically like I like to revise this transaction. So this happened in the blockchain analytic. For example, sometimes I have the transaction, but later they need to do they call the reorganization. I need to revise the transaction. Need to revise the transaction means that I need to correct the amount. The amount right now is like 433,000. I like to correct this number. So we can do we can revise this one. For example, this account I did using this this transaction. I need to revise this transaction with this with a different amount. Like different amount is like 40,000, and also like a bump is just 3 and update. It basically update the it will basically do the update automatically. See right now, it actually emitted another transaction, another aggregation result. Previously is 43,000, 4,323,000, and right now it's basically the amount has been corrected. It's basically decreased. The total amount has been decreased. This is very super important. In a regular database, it's really hard to do that because whenever there's a small amount of data need to revise or update it, they need to rescan all of the data, to reprocess all of the data again to get the correct results. So in our case, basically everything will happen incrementally and automatically, and in real time with small amount of memory footprint. The last thing I like to show is basically do the to show the internal query processing pipeline is actually very complicated compared to traditional regular database. We have the hybrid changelog processing, we have the watermark processing, we have the global aggregation. Everything is basically happening online in very complicated processing because we need to do the data revision and also do the changelog checking. So and also we are enabling the hybrid hash table to save the memory. And there's a very good balance between the memory utilization and the and aggregation performance. Yeah, this is all I like to share. I'll hand over to Jove. Thank you.
Yeah, thank you. And yeah, this is very impressive. This is just one of our key feature in the recent release, and now we are moving in this monthly release cadence. So we released the 2.6 recently with this hybrid hash table, hash join, and we significantly improved the visibility for you to understand what's going on with your checkpoint, with sequence number, to the troubleshooting. And we also have this new Grafana plugin integration, and we have a lot of other exciting features coming. For example, the 2.7 will include the dictionary, and also you can put your object in different databases for the isolation. And the Python UDF, the Iceberg, and stateless materials view is coming very soon. And if you see anything relevant to your use case, contact us to get early access to the 2.5, 2.7 new version. And you can also join the webinar next month, almost same time, and we'll talk about those features. So yeah, for example, also we update the UI side. Let's say we have this new quick access. You can just using the Command K or Control K to jump to a particular dashboard stream. It will be very convenient. And also in our CQ console, we also redesigned the entire interface. So you have more room to write complex CQs, and you can save them as a bookmark, or refer to other functions or common snippets. And the Timeplus Proton is our core engine, and since we open source it September 2027, we get a lot of support from all of you. Thank you for the support. And please try this and see whether it can be useful for your day-to-day data engineering work, and give us a star to bookmark it and give us some feedback. And last year we released 30 versions, and we will continually update it at the bi-weekly cadence. So the recent features such as the debugging feature in the JavaScript UDF, and we have this new time-weighted aggregation functions. It is very helpful for you to process the data, not consume too much storage. And the new external stream for Apache Pulsar and for Timeplus can help you to connect different Proton instances together. And upcoming, we will also support S3 and SBIRD and Python very soon. So again, you can just go to GitHub, our Proton repository, and try to use it. It is available for Mac, for Linux as a Docker image. And it's just a single binary. It's very easy to install and use CQ to build your data pipeline. So that's pretty much for the content we prepared, and maybe we can still take 1 or 2 questions, no matter for us, for Jason, for any feedback. That'll be really appreciated. And yeah, you can also join our community Slack. So this is a shortcut, timeplus.com/Slack, and you can put a question there.
So the first question is from Sanas. Thank you so much for the ask. For the hybrid hash table, is it also available in Proton or only in Timeplus Enterprise? Right now, it's only in Timeplus Enterprise for this feature. Another question is comparing ClickHouse or any other OLAP, what's the difference and the uniqueness? Yeah, so this is a really good one, and also the answer could be lengthy. So from my perspective, so basically, Timeplus is basically a incremental engine. I think this is key differentiation, incremental engine first. So basically, we can incremental doing the aggregation and join compared to traditional database. You need to rescan everything for loop and sleep to rescan everything, reprocess all of the data. This is the first key differentiation. The second one is absolutely data mutation processing. Data mutation processing or data revision processing, just as I demoed, is a very key differentiation. So lots of our customers, especially for the financial service and also blockchain, this data mutation. And some of the data mutation can happen very, very quickly. Some of the data mutation happened pretty frequently, but with a very high cardinality of data. In this kind of data mutation and incremental query processing together, they will be very, very unique in streaming aggregation, streaming or join. In regular database, it's really hard to do that, or it's very expensive to do that. Yeah. So this is basically two big difference. And another one is basically a high scale data processing, incremental query processing pipeline. This is something regular database is basically cannot do. So in regular database, it's not like a streaming transformation, streaming ETL. Yeah. Joe, do you have anything to add regarding the difference and the uniqueness?
Yeah, seeing is believing. I will say, yeah, there's a lot of theory, there's a lot of enhancement we did, but yeah, if you can try either Timeplus Bottom or Timeplus Enterprise, you can connect to your Kafka and you can run some query, you can immediately see the difference.
Right.
So
this is well said. Yeah. So seeing is believing for sure. Yeah, this is a very good say. So absolutely, analytical streaming data in Kafka. Absolutely, traditional database is really hard to do that without doing any kind of indexing even.
Yep, Timeplus is very unique. So yeah, try Timeplus and give some feedback, and we're happy to discuss more. Yeah, I guess we might have to wrap up because we don't want to run over time for your next meeting. So thank you for joining this, especially Jason, to sacrifice your lunchtime and sharing your awesome use case. And you also give us a lot of feedback to improve the Grafana plugin. And this also benefited for our other users. We appreciate that. And thank you, Ken, for the awesome introduction deep dive. And we are going to publish a blog regarding the detail about the hash table and also the new feature in the recent release. And you can also expect the other webinar in next month in the 20-ish. So we'll do this in the monthly cadence, no matter for the product, new feature enhancement, or some of the custom story. And if you are using Timeplus Proton or Enterprise in any use cases and want to share a little bit more, yeah, feel free to join and contribute back to the community. And join our Slack. You can chat with us anytime. Okay, thank you very much. And subscribe to our linking account and join our Slack and the chat and meet you next time. Thank you, everyone. Have a good day.
Thank you, Jason. Thank you, everyone.
Thank you.
Thank you.
Thank you. Very cool. Thank you. Bye.